Hey everybody, welcome back. So today we're going to be looking at information security again. Ask browser to access your site via HTTPS only with helmet.hsts. As a reminder, whatever, HTTP Strict Transport Security, HSTS, is a web security policy that helps to protect websites against protocol downgrade attacks and cookie jar hijacking. If your website can be accessed via HTTPS, you can ask users' browsers to avoid using insecure HTTP by setting the header strict transport security to tell the browser to use HTTPS for future requests in specified amount of time. This will work for the requests coming after the initial request. So configure helmet HSTS to use HTTPS for the next 90 days. Pass the config object, max age, time in seconds, and force is true. And you can create a variable 90 days in seconds, which is 90 times 24 times 60 times 60. To use the time in seconds. REPL it already has HSTS enabled. To override its settings, you need to find the field force to true and config objects. We will intercept and restore REPL it header after inspecting it. Okay, this isn't important to us because we're doing it via GitHub and render. We're deployed via render service. Configuring HTTPS on a custom website requires the acquisition of a domain and an SSL TLS certificate. So we might not even be able to test this. But anyways, for now, let's just test to see that our existing application doesn't have this. So yeah, it says the middleware should be mounted correctly and the max age should be equal to this guy. Yeah, cool, no problem. So if we pull up our code, let's look over here. So we want this guy, helmet HSTS. So app.use helmet.hsts. Okay, HSTS, and we want to pass it this guy. Oh my word. FreeCodeCamp doesn't let you copy off of it anymore. So we'll just copy it over or push these things over here and we can just type it out. So max age, time in seconds. Force, true. Okay. And then we're going to have to set a const of time in seconds. We'll set that equal to yeah, we might as well just do it the way they tell us. 90 times 24 times 60 times 60. Nice. Okay, so if I save that, just to make sure that it's right, let me test this. I'm going to close the thing and just go node 7776000 7776000. Okay, cool. So we can get out of node. We've got time in seconds there. We've got a force to true. Okay. So what happens if we save this and then run it npm start? Let's come back to our local environment. So here's our local, and we'll refresh the page, see what happens. So let's see if we have time XXS protection. Oh man, I wonder if that's from that previous video. Here we go, strict transport security, max age of that. Include subdomains. Interesting. Okay, so let's comment our new code out and then stop the server and restart the server. And now we're going to see if this strict transport security is still there, even though I'm pretty sure it's not going to be. So we look under the local. We don't see strict transport security. So it just basically sets the headers. That's all this guy does. So we can save that. Might as well stop and start the server locally, even though it doesn't matter. In our next browser, we can go get status. And if we go get diff, we can see that our we've added 2 lines to the program. So we can go get add and then git commit. And here we're going to say we're going to add HTTPS requirements via helmet. And we can go git push. Cool. And so now we've pushed that up to our develop environment. So if we come back to here and we look into our render, our dashboard, we're going to see that there's a deployment in progress. And that is setting this up. And so, yeah, if we were to do this right now, oh yeah, we already tested to make sure that it fails. The middleware was done incorrectly. So we're just waiting for this to be deployed, and then we'll look it up. So in the meantime, let's look into this a little bit more. HTTPS, Strict Transport Security, is a web security policy which helps to protect websites against protocol downgrades. Let's just do a Wikipedia on this. Man, it's really not nice that FreeCodeCamp doesn't let me. HTTPS Wiki. Strict Transport Security is a policy mechanism that helps to protect websites against man-in-the-middle attacks, such as protocol downgrade attacks and cookie hacking. It allows web servers to declare that web browsers or other compliant user agents should automatically interact with it using only HTTPS, which provide transport layer security, unlike the insecure HTTP used alone. HTTPS is an IETF track protocol. Is a cryptographic protocol, transport layer security, designed to provide communication security over a computer network. The protocol is widely used in applications such as email, instant messaging, and VoIP, but its use is in securing HTTPS remain the most publicly visible. Okay, so how's the deploy? Still going? All right. Keep researching this then. Cookie hijacking. That is a funny thing to say. Session hijacking. In computer session hijacking, something also known as cookie hijacking, is the exploitation of a valid computer session, sometimes also called a session key, to gain unauthorized access to information or services in a computer system. Yeah, if you want to look at your cookies, you can look at them here. And then this will give you information about what's in there. So there's all sorts of different information. And so when you're debugging authentication protocols, oftentimes session data is the critical thing that gets you access to the systems. Okay, so it looks like our deployment has gone live. So if we look at here, we did not have anything about that 7177, or what was it? We did not have anything related to the 7776000. And so this is in the deployed environment. And now if I refresh, because this is before the dynamic, and now if I check this again, now we have it. So we've added this to it. So this is just adding header requirements that are useful for security, I suppose. So yeah, we completed the challenge. Looks good. All right, we're 50% through. Thanks for watching. We'll see you in the next video.